My name is Mr. Philip Onyango. We'll continue with algebraic expression in this lesson 3. So, as I told you before, yesterday, I said that we were supposed to be tackling word problems of algebraic expression. So, I will write the topic. So we'll still continue with algebraic expression, but word problem. So I'll write here word problem. Word problem simply means there are algebraic questions, but they are written in sentences. So as I will start with my question 1. Question 1 is find the perimeter of the figure below. Find the perimeter of the figure below. Find the perimeter of the figure below. So when I'm talking about the perimeter simply means distance all around a given figure. The figure can either be a rectangle, square, trapezium, parallelogram, or even a rhombus, any figure. So I will draw my figure here as my Roman 1. So this is my figure. This side it is a plus 3 meters, while here is 4c, then here is 2k, this side is also 2k. When you look at this particular diagram, the distance from here to here, I hope you are looking at my hand, the distance from here to here is a plus 3m. So it means that the distance from here to here is the same as the distance from here to here. So when here is a plus 3m, here also will be a plus 3m. I repeat, from here to here is a plus 3m. The distance from here to here will also be a plus 3m. When you look at down here, we are having from here to here is 2k. From here to here is also 2k. Therefore, for us to know the distance from here to here, the distance from here to here, we will use imaginary lines. Imaginary lines are the dotted lines. So I will create an imaginary line from this particular point, stretching upwards until I touch this given line. So I will put an imaginary line, dotted line. Then also here I will put a dotted line. So when from here to here, if it is 2k, from here to here will also be 2k. I repeat, here to here is 2k, here to here will also be 2k. So here will be 2k. From here to here also is 2k. From here to here will also be 2k. But remember, the distance from here to here is the same as the distance from here to here. The distance from here to here is also the same as the distance from here to here. So when here to here is 2k, here to here is also 2k. Here to here 2k, here to here is also 2k. But remember, when you look at the middle part, from here to here is 4c. So when here to here is 4c, it means that here to here will also be 4c. So when we have all these distances, what we'll do here, you've been given a point from here to here. When you look at the diagram, from here to here, they have said it is E. From here to here is E. It therefore means that from here to here will also be E. Therefore, the question is, find the perimeter of the figure below. Perimeter means distance all around a given figure. So we'll be moving from this particular point, moving like this, going downwards, making a curve, going this way, this way, this way, this way, then we join at this particular point. Therefore, it means that the dotted lines will not be perimeter. So I will come here and say perimeter is, whenever I write a distance, in this given figure, when I write it down here, I will make a tick so that it will indicate to me that that particular distance I've already dealt with it, to avoid repetition. So I will start moving from here to here. From here to here is A plus 3m. It will be A plus 3m. So I will tick it. Then from here to here will be 2k, so it will be plus 2k. I will also tick there. From here to here is E. I will write plus E. I will tick it. From here to here is 4c. I will write plus 4c. I will tick it. From here to here is E. I will write plus E. I will tick it. From here to here is 2k. I will write plus 2k. I will tick it. From here to here is A plus 3m. I will write plus A plus 3m. Then from here to here is 2k. I'll say plus 2k. I will take this, I'll take that. Then from here to here is 4c. I will say plus 4c. I will take it. From here to here is 2k. I will say plus 2k. Then I will write equals. So when I add all these given distances, I will come up with the perimeter of this given figure. So I will say, how many A's am I having here? 1. I will collect the like terms. 2. So I'm having a total of 2 A's. Plus, how many M am I having? 3M. There's also another M here. So 3M plus 3M, I will be able to get 6M. Plus, how many K's am I having? I'm having 2K, going around 2K, again 2K, then again 2K. So total, how many 2K's am I having? 1, 2, 3, 4. That one means 2K plus 2K is 4K, plus 2K is 6K, plus 2K is 8K. So plus 8K. Plus, how many E's am I having? E plus E, that is 2 E's. Plus, how many C's am I having? 4C, plus again 4C, that is 8C. So this is 2A, I'm having 6M, I'm having 8K, I'm having 2E, and I'm having 8C. All of them are separated by the sign plus. So when you look at them, all of them are having different letters. That one means the perimeter will be the letter that those values, those numbers are having. So we'll stop at there. We'll just write it again. Say that it is 2A plus 6M plus 8K plus 2E plus 8C. That is the perimeter of this given figure. So for us to know that we are either right or wrong, we'll look it again. A, we are having 2 A's, that is A plus A, that is 2A, that is correct. 2K plus 2K, that is 4K, plus 2K, that is 6K, plus 2K, that is 8K, that is correct. M, that is 3M plus 3M, that is 6M, it is there. E, we are having E and E, that is 2E. Then C, we are having 4C and again 4C down, that is 4C plus 4C, it is 8C. So all these values are unlike terms. Therefore, that one will be the answer of that given perimeter of that particular figure. Therefore, we are going to the second part of the question, number 2. Number 2 says that Onyango is 20 years. Sorry, Onyango is 20 years. Onyango is 20 years older. Onyango is 20 years older than his son. Question is, Onyango is 20 years older than his son. Then Roman 1 says, find the sum of their present ages. Find the sum of their present ages. The question is, Onyango is 20 years older than his son. Find, Roman 1, the sum of their present ages. Find, Roman 1, the sum of their present ages. So when we look at this particular question, the first thing that you're supposed to look at, how many people are we having in this particular question? We are having a person known as Onyango. Then Onyango himself is having a son. So we are having two different people. That is Onyango. I will write here Onyango. Then I put equals. Then I'm having here son. Then I write equals. So we are having two different people. Onyango is 20 years older than his son. Onyango is 20 years older than his son. Do we know the age of the son? We don't know the age of the son. As I told you before, the age of the son will be given a letter X. So the first thing that you'll do is, I'll come here, I'll say, let the age of the son, let the age of son be X. Let the age of the son be X. Therefore, after writing let the age of the son be X, I will underline it just for it to be attractive to the teacher who will be looking at that particular question. Therefore, after writing let the age of the son be X, I will look at the question and I'll see that we are having two different people. That is Onyango and son. So I will write here Onyango equals, then I will write here son equals. So we have already mentioned that let the age of the son be X. So son will be X. And Onyango is 20 years older than his son. So that one means Onyango is 20 years older. That one means it will be, Onyango will now be X plus 20. If the age of the son is X, Onyango being that is 20 years older than his son, Onyango will be X plus 20. So the question is, find the sum of their present ages. I will underline the word sum. Sum means addition. So sum of their ages, sum will equals to, Onyango, it is x plus 20. The word sum in mathematics means addition, plus the age of the son, which is x. Therefore, when you come here, you will collect the like terms. It will be x plus 20, which will be x plus x will be 2x, then plus 20. So 2x plus 20, we cannot add it because they are unlike terms. So being that they are ages, I will put bracket here, then I will write here years, just to show the teacher who is looking at your work that whatever you are talking about is ages. So our final answer will be 2x plus 20. Roman 2 part of the question says that find the sum of the ages. The sum. They want you to find the sum of their ages. They want to find the sum of their ages, the sum of their ages the sum of their ages in 5 years time. In 5 years time. The sum of their ages in 5 years time. The sum of their ages in 5 years time. So as I will give you an example, if Mr. Philip right now is 24 years of age, when somebody asks you what will be Mr. Philip's age in 5 years time, it will be the age, the present age of Mr. Philip, which is 24, plus 5. So in 5 years time, Mr. Philip will be 29 years old. So I will come back here and look at the present ages of Onyango and son. So I will come and write the same individuals. We are having Onyango. I put equals. Then we are having son. I will also write equals. So when you look at Onyango, Onyango's age is x plus 20. That is the age of Mr. Onyango right now. The age of the son is x. But when you go back to the question, the sum of their ages in 5 years time. If Onyango is x plus 20 years of age now, in 5 years time, you will take the age of Onyango, x plus 20, then you add 5. So Onyango's age now is x plus 20. In 5 years time will be plus 5. So that one will be the age of Onyango. Son age is x right now. In 5 years time, the son's age will be x plus 5. It's a matter of just adding 5. 5 years time means future. So you add 5 in your present age. So it will be the sum of their ages in 5 years time. I will come here, I will write sum is equals to, Mr. Onyango's age in 5 years time will be x plus 20 plus 5. So it will be x plus 20 plus 5 plus the age of the son right now is x plus 5. So their total sum, you add again the age of the son, x plus 5. Then you come here, you must make sure that you arrange your work in a good way. You'll collect the like terms. You'll say x plus 20 plus 5 plus 5. So x plus x, we are having 2x plus 20 plus 5 is 25 plus 5 is 30. So it is 2x plus 30. Then you put the bracket. What are we talking about? Ages. ages are usually in years. So you'll write here, years. That is it. So when we are looking at the third part of the question, that is Roman 3. So Roman 3 part of the question, you are asked, it's the same question, but Roman 3 part of it. Roman 3 part of it, you are asked, let me write the question, Roman 3, you are asked, the sum of their ages, 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 the sum of their ages 3 years ago. The sum of their ages 3 years ago. Remember, we are still having the same individuals. We are having Onyango equals, then we are having Sun equals. Remember, Onyango's present age was X plus 20. I believe you can remember that. And the Sun's present age was X. But the question is, the sum of their ages 3 years ago. 3 years ago simply means backwards. If Mr. Onyango's age right now is X plus 20, what was Mr. Onyango's age 3 years ago? You will subtract 3, minus 3 from his present age. The Sun's age right now is X. What is the Sun's age 3 years ago? X minus 3. So we'll come to the sum of their present ages. The sum of their ages 3 years ago will be Mr. Onyango's X plus 20 minus 3, which will be equivalent to X plus 17. That one, let me write Onyango. That is Onyango's age 3 years ago. When you come to the Sun's age 3 years ago, as you can see here, is X minus 3. X minus 3. Therefore, when we look at the sum of their ages, sum now, 3 years ago, will be X plus 17, that is Mr. Onyango, plus X minus 3, which will be, you collect the like terms, X plus 17 minus 3, which will be X plus X, we are having it to be 2X, plus 17 minus 3, we are having it to be 14. Then you put bracket, you write years. So the sum of their ages 3 years ago, Mr. Onyango and the Sun, was 2X plus 14 years. That one you have to know that and take keen note of that. Remember, when you want to always calculate the ages of individuals in an easy way, the first thing, you must always write the names of those very individuals. Then you write their present ages. So when somebody asks you 5 years time, you just put plus 5, then the other person's age plus 5. But when somebody asks you 3 years ago, you write their present ages. Then because it is 3 years ago, that one means backwards, you just, the present age of that particular person less 3, the present age of that different individual less 3. So the question will always be easy. When you go to the last part of the question, you are asked, the product of their ages 3 years ago. So I'll write the product. You are asked to find the product of their ages, the product of their ages 3 years ago. So they want you to find the product of their ages 3 years ago. Mathematically, the word product means times. So we look at what was their ages 3 years ago. From Roman 3 part of the equation, you can get that Mr. Onyango's age 3 years ago was x plus 17. So I will just copy it directly from Roman 3. Onyango, age 3 years ago was x plus 17. When you come to the son's age 3 years ago, you can see from Roman 3 was x minus 3. Just come back and write x minus 3. So we are having x plus 17, we are having x minus 3. Then they want product. From the beginning, when I was introducing algebraic expression, I taught you how to expand given numbers. So Mr. Onyango's age is x plus 17. Put bracket, because that one means the age of one particular individual. But because it is times, I'm not going to write here times. I will simply put another bracket. As you always know, a bracket also means multiplication. Then I will put bracket, I write the age of the son, x minus 3. So we are having x plus 17. Then we are also having bracket x minus 3. So what you're supposed to do is this. We are going to expand this, then the final answer will be the product of their ages 3 years ago. So in the first part of the bracket, we are having x plus 17. We pick one number or letter, then we open a bracket, we write the second bracket the way it is. So here we are having x. I will write x from the first bracket. Immediately you write the first number, you open bracket, then you write the second bracket the way it is, x minus 3, then you close. When we took x from here, we were left with positive 17. So I will write positive 17, or rather some students will always say plus 17. Open bracket, then the second bracket, you copy it the same way you had copied it before. That is x minus 3. Therefore, when you look at it, you can now break it by multiplying. You open the bracket. X times x is x squared. Then we are having minus is here. I put minus. X times 3 is 3x. We are having positive here. I'll write positive. 17 times x is a 17x. Positive multiplied by a negative number, you get negative. 17 times 3, you get 51. Then you collect the like terms. X is squared here. There is no x which is squared. So you'll just copy it again, x squared. Remember, I told you in our previous lesson that when you look at -3, negative number, in mathematics, negative number is always a debt, while a positive number is always money in the pocket. So this individual had a debt of 3 shillings, but in his pocket, he was having 17 shillings amount of money. So when he paid a debt of 3 to that particular individual whom he owed money, how much was he going to remain with? You just subtract direct. So 17 minus 3, you get positive 14x minus 51. But because they are ages, you just put bracket, then you write years. That one will be the final answer in that particular area. Then when we go to our number 3 part, number 3, let me write it first. Remember, we are still dealing with word problems, algebraic expression, Form 1 work. So the question is, number 3 says, is a different question now. That whatever we were doing was number 2. So number 3 question right now is the price of 1 kg of meat. The price of 1 kg of meat. The price of 1 kg of meat was 2x plus 2. Was 2x plus 2. That one is in shillings. Let me write it well. Was 2x plus 2 shillings. Then Mr. Rogers, bought 10x kg of meat, 10x kg of meat, comma, how much did he spend? How much did he spend? So that is the question. The price of 1 kg of meat was 2x plus 2 shillings. Then there's a full stop. Mr. Rogers bought 10x kg of meat, comma, how much did he spend? So you'll come here and say, if 1 kg of meat cost 2x plus 2 shillings. If 1 kg of meat costs 2x plus 2 shillings, therefore 10x kg of meat will cost how much? Remember, we can never put equal sign here and here. We can never put equal sign here and here because this one is 1 kg. We cannot say is equals to shillings. There's no way kg can be equals to shillings. So we use arrows there. We say if 1 kg of meat is equivalent to 2x plus 2 shillings. Therefore, 10x kg of meat will be how much? So we cross multiply. That one will be 10x kg times, you just follow the arrow, shillings, 2x plus 2, everything over 1 kg. You write it like that, then you put bracket. You write it like that, then you put bracket. You write it like that, then you put bracket. So 10x kg times 2x plus 2 shillings over 1 kg. You'll come here, you say, the kg will cancel kg. So remember here we are having 10x. You'll write 10x. Then always open bracket after writing 10x because bracket means times. So we don't put times here. When you put times, it will always confuse you. Just put bracket to represent times. Then the shillings here is 2x plus 2. So you inside the bracket you write 2x plus 2. Therefore, after that you multiply, you open the bracket. So that is 10 times 2, you get 20. but x times x, you get x squared. Then here we are having plus, you put plus. 10 times 2, you get 20. But what we have is x. Remember, this is amount of money, it is shillings. So we'll write shillings after multiplying 20x squared plus 20x. So this one will be our answer right there. This one will be our answer right there. So in our final question, last question for today, number 4 is the sum of the first, the sum of the first three consecutive even numbers. The sum of the first 3 consecutive even numbers is 18. Then the question is find the numbers. Find the numbers. The sum of the first 3 consecutive even numbers is 18. Find the numbers. Remember yesterday, I taught you in our previous lesson, I taught you consecutive numbers. So the first consecutive number in normal numbers, remember they are even numbers. Our normal even numbers always starts with 2, then we go to 4, then we go to 8, just to mention a few. So from 2 to 4, you add 2. 4 to 8, you add 4. But remember, there's one that I've skipped, which is 6. But now, when I just put 6 there, to avoid confusion, 2, 4, 6, then 8, then 10. Let me put at least more. So 2 to 4, you add 2. 4 to 6, you add 2. 6 to 8, you add 2. 8 to 10, you add 2. Then it continues like that. So you can see 2 to 4, you add 2. 4 to 6, you add 2. 6 to 8, you add 2. 8 to 10, you add 2. So in completion, you will realize that the common even numbers are 2, 2, 2. So the first even number, I told you that the topic is all about letters, will be x. Then the second one, from 2 to 4, when you look at the normal numbers, you add 2. So it means the second one will be x plus 2. Then from 2 to 6, how many are you adding? 6 minus 2, that is 4. So the third one will be x plus 4. So when you look at these particular numbers, you'll realize that these are the first 3 consecutive even numbers. You are being told that when you look at the first 3 consecutive even numbers, when you add them, you get number 18. So it therefore means that x plus 2 plus x plus 4 will give you 18. It therefore means that when you collect the like terms, it will be x plus x plus x plus 2 plus 4 will give you 18. So it will be 3x plus 6 is equals to 18. Therefore, 3x is equals to 18 plus 6 minus 6. Therefore, 3x will be 12. You divide every side by 3, every side by 3. So therefore, x will be 4. It therefore means that, remember our first even number was x. Let me underline it. So our first even number x is equivalent to 4. The second even number is x plus 2. So I will write here x plus 2 is equals to, remember x is 4. So x plus 2 will be 4 plus 2, which is 6. Then the third even number is x plus 4. So it will be x plus 4 will be equals to what? X is 4. So x plus 4 will be 4 plus 4, which is 8. Which is 8. It therefore means that when you look at these particular numbers, our even numbers will be, these ones here will be 4, 6, and 8. These ones are the numbers that we are looking for, 4, 6, and 8. But for you to confirm if you are right or wrong, you can even add them. 4 plus 6, you get a 10. 10 plus 8, you get 18. Then they were telling you the sum of the first three consecutive even numbers is 18. It therefore means that we are actually right, 4, 6, 8. So this one you must always practice as a student. You will always realize that these are the basic items that you must know. So in our next lesson, we'll move with evaluation, now completing the algebraic expression topic. Thank you.